75% of the purchase price, and the bank granted him a loan at an interest rate of 9.5% per annum, compounded quarterly, to pay off the balance of the purchase price. David agreed to pay quarterly installments of 58,000 rand starting on 1 January 2011. So the first question says, how much money did David borrow from the bank? Now here, because he borrowed 2 million and then he decided to pay a deposit, we need to know how much money was that deposit. So to get the amount that he borrowed, it will be 75% of 2 million, right? So 6.1, there are two ways of doing it, okay? There are two ways of doing 6.1. All right, I'll just share with you both methods. Method 1, so the amount borrowed, I'll call it P. So it will be equal to 2 million minus 25% times 2 million. Okay, 25% of 2 million is 500,000. So this will give you 2 million minus 500,000. Then you get 1,500,000. Okay, so this is method 1. Method 2 is the shortest. Method 2, we can just calculate 75% of 2 million. So we'll say P is equal to 75% times 2 million. And that will give you 1,500,000. Right? So any of those two methods will, right? The amount borrowed accumulates interest for 1 quarter. Okay, so we are going to use the compound interest together with the present value formula. Okay, now it's very important for you to know that since here our N, okay, the question says how much did we want to get N, was that it says how many quarterly installments, right? So it means we are going to use the compound interest formula. So I'll write here P times 1 plus I raised to the power of N1 is equal to X times 1 minus 1 plus I raised to the power of minus N2. This is all over I. Where there is N1, we put 1 because the person only skipped 1 quarter before he made the first payment. So we are going to have 1,500,000 times 1 plus I. Our interest is 9.5% compounded quarter, so that's 0.095 over 4, all raised to the power of 1, and that's equal to X. Now, X is 58,000. 1 minus, this is 1, minus 1 plus 0.095 over 4, all raised to the power of minus n. Okay? But here I'm just putting n, but you can put n2, but our n2, I'm just calling it n there. Okay, it's not a big deal. You can put n2 if you want, it's not a big deal. Then, so we want to get that minus n, right? So, the best way is to just simplify the left-hand side. Okay, so I need someone to do a calculation for me, right? To multiply what's on the left by this, whatever answer you get, you divide it by that and tell me the answer. Whatever is on the left, you multiply by this fraction, then the product you divide it by 58,000.
Sir, I already did the exercise, so then I just left it like this in my answer. I'll calculate it quickly now for you, if no one else does.
Okay. Take it to the left hand side. So it becomes positive. So it will be 819 over 800 raised to the power of minus n. Then the next thing, can you subtract this 0.6228 from 1?
Yes, sir.
You get 0.3. Your choice. You can convert the exponential equation to a logarithmic equation, which is the method that we have been using. So this becomes minus n. To be minus n will be equal to the logarithm, okay? The logarithm of 0.3711880388, right? To the base of 819 over 800. So, what will be your n then?
It is it's 42.22.
42.22, right? So that will be 42.22. Now, because the question is asking for, okay? So, because of that, we say therefore, our n is going to be approximately 43 payments. Okay? The question is not asking for the number of years, but it's asking for the number of payments. So, there are going to be 42 full payments. The final payment is not going to be of 58,000. Right? So you need to make sure that you write that the final payment is going to be 43. The number of payments, it has to be an integer there. Okay? It has to be an integer. It cannot be a rational number. All right? You need to be aware that the year starts from 1 July 2010 to 1 July 2016. That's a total of 6 years. In 6 years, there are 6 times 4, which is 24 quarters. Among those 24 quarters, he skipped on one of them. He didn't pay a cent. So he's going to pay 23 times. Okay? He's going to pay 23 times to get to the balance outstanding. Okay? So I'm going to use the first formula. Right? Now for this question, if you remember very well, we did a question which was almost like this one, whereby we were not, I prefer to use method 2, then we realized that if we round off, we're going to end up having a slight difference. And then we end up making a conclusion that if you want to use method 2, if the n is a decimal, okay, if the n is a decimal, use it as it is, as a decimal. Don't round it off. Okay, so if you use method 2, the n that you're supposed to use is the 40, if you use method 2, it will be 42,22 whatever minus 23. But if you use method 1, you use your n as 23. Alright? So, how much money did he borrow? The amount that he borrowed is going to be, here we'll put P is going to be equal to 1, is going to be equal to P is going to be equal to 1,500,000 times 1 plus I, which is 0.95 over 4, all raised to the power of 1. What answer do you get? This is the amount that the person borrowed. Can you
1,535,625.
Yes. How many cents?
No cents, sir.
Okay, so it will be 0. So the person borrowed this amount because of the delay in making a what? A first payment. Then, when we are calculating the balance outstanding, this value is going to be our P. So the mistake which I made earlier was for putting 1.5 million instead of calculating this value. So in this formula, maybe I can just call that one K. That would be minus X times 1 plus I raised to the power of K minus 1 all over I. Okay? So, when there is P here, I was supposed to put 535625 because of the delay in making a payment. Alright? So that would be raised to the power of 23 minus X is 58,000. Okay, so that's 1 plus 0.095 over 4, all raised to the power of 23 minus 1, divided by 0.095 over 4. So if you simplify this, what do you get?
886,790,15, which is the same answer as the last one.
Okay, so this is now correct. The two answers have differed because I made a mistake in terms of substitution there. I put 1.5 million there instead of what? Well, instead of calculating the amount that he had borrowed, which included the interest which accumulated because of the delay in payment. All right. So, if you use the second method, right? So this is method 1. If you use the second method, right, just make sure that this is all clear. The formula will be x into 1 minus 1 plus I raised to the power of minus n minus k all over I. So that will be 58,000 times 1 minus 1 plus 0.095 over 4, all raised to the power of minus. This is where we put 42.22 with all the decimal digits, then we subtract 23. Okay, and all this is under 0.095 over 4. So so it means your balance will end up becoming the one we got here, which is 886,790.15. Okay? So, are we all clear now? This whole question from the Northwest. Now, the 6.4 says, hence calculate the amount of interest that David had paid on his loan until immediately after paying his quarterly installment on 1 July 2016. Okay? Remember, up to 1 July 2016, he made 23 payments. Okay? Up to 1 July 2016, he made how many payments? 23 payments. Okay? But if we want to calculate the interest, okay? The interest, there is a specific formula which you're supposed to use for a scenario like this. So that formula is this. Your interest, okay, that the person is going to pay up to, okay? Remember, the question says, hence calculate the amount that David had paid on this loan until immediately after paying his quarterly installment on the 1st of July 2016. How much interest? That interest we get by multiplying the monthly payment times the number of payments. Okay? The amount we get here, that 58,000 times 23, it gives us the total amount that the person paid, which included interest. Remember, the 58,000, it is calculated, it is an amount that a person pays together with interest, because the person would have borrowed. So you made 23 payments. Then the person originally borrowed, okay? The person originally borrowed how much? It was 1,500,000. Okay? The person originally borrowed 1,500,000. Okay? So if you borrowed 1,500,000, this is the amount which was originally borrowed. Right? Now we need to add, okay, the amount that the person is gonna have to pay in terms of the balance outstanding after that 23rd payment. So the 23rd payment, we got it in the previous question. Okay, this part is a little bit tricky. This amount here, 886, up to the balance outstanding. This is the total amount that the person has paid, up to the balance outstanding. Okay, that is after the 23rd payment. The amount borrowed is 1,500,000. Right? The balance outstanding, it includes the amount which included the delay in payment. So, if we want to know how much money has the person paid, okay, paid off from the 1,500,000, we need to find the difference between these two. Remember, this amount here, it is not up to the end of the amortization of the loan, but it is a balance outstanding after a specific period of time before the full duration of the loan. So if you want to know from the 1,500,000, how much has the person paid, okay, we can get that amount by subtracting this amount from 1,500,000. Whatever difference we get there, that's the amount which will seem like the person has paid it off from the 1,500,000, which is the original amount that the person borrowed from the bank. And be aware that this 886, 790 and 15 cents, it includes the amount which you got from the delay in payment for a court. So, can you recalculate, Tesha?
Yes, sir. So I made a mistake last time. Last time I gave the correct answer with the minus accidentally. But if we did use the plus instead of the minus, we would have got an answer, which is the wrong answer, by the way, of negative 1,052,000. But the correct answer is the last answer, which is 720,790,15. I didn't include the brackets, so the minus that would have turned that minus into a plus was already taken into account last time. Sorry about that.
No, it's fine. So, this is the final answer. I hope the others, they also did the calculation and they can confirm that as well. All right? So, up to the balance outstanding, the person would have paid 720,790.15 as interest. All right. Now, I also encourage you, if you get the chance, okay, your textbook has got one example where they do a calculation of this nature. It's on page 86. Okay, it's on page 86. They do a calculation of this nature. Right? There are two ways of doing it, or we could have calculated the interest as 58,000 times 23. Okay? Then we can add that 886, 790 and 15 cents. Then we subtract the 1,500,000. you still get the same result. It's more like it's just a choice in terms of how you prefer to do the problem. Okay, so if you go to page 86 of your math textbook, there's an example which was done there of a question of this type. It's a little bit tricky in terms of the approach. Okay, and don't forget that this amount, it still has to be paid and is going to accumulate interest. Okay, this amount, it still has to be paid together with the interest that it's going to accumulate. Unless if the person has got the amount and they can pay it as a lump sum after the 23rd payment. Otherwise, if it takes more time, it will accumulate interest and it will go higher, it become higher and higher and higher.